In a previous video, I showed you how to find the area underneath a standard normal distribution curve in Excel. What if we have real data that doesn't have a mean of 0 and a standard deviation of 1? We learned in class that in order to do that, we needed to find the z-values, and then we use those z-values to find the area to the left or right or in between in our table. But Excel makes that a little bit easier without having to find those z-values. It has a function built in that will, given the mean and standard deviation, will find the z-values in the area to the left or right or in between for you, so probabilities. To demonstrate that, I'm going to do a problem in your book. It is in Chapter 6, Section 2. Number 11, and that's in the 7th edition. And it says that the average credit card debt for college seniors is $3,262. I'm going to write that down. Okay, and it says that the debt is normally distributed with a standard deviation of 1,100. So get that as well. And we're going to find the following probabilities. A asks for the probability that the senior owes at least $1,000. I'm going to type that 1,000 here as well so I can click on it for my formula. So I want the probability that we owe at least $1,000. The Excel formula does give the area to the left, so I've got to figure out what I'm being asked for here, and if I need to translate it, do that. So at least is $1,000 or more. So that is actually what we're wanting, is the probability of X being greater than $1,000, or the area to the right of that value. So we're going to have to do 1 minus the area to the left. And in Excel, the area to the left, we use the norm dist function, so without the s from before, with the standard. This is not the standard distribution, this is real data. So it asks for 4 things here. First, it asks for x, which is our $1,000. We're looking for the probability that x is greater than $1,000, so this is our x. It then asks for our mean, which we wrote down over here, and our standard deviation, which is right here. And then it asks whether it's cumulative or not, and we actually are in a cumulative distribution because we want the whole area to the left of $1,000. We don't want just the area underneath $1,000. That would be asking us for the probability that the senior owes exactly $1,000, and that would, if we were wanting that, we would put false there. But we're wanting at least $1,000, so $1,000 or more, area to the right, so we are wanting a cumulative distribution here. And there we go. So our probability is about 98%. Let's do B. B asks for the probability that the senior owes more than $4,000. Check that out. Okay, so more than 4,000, that's a greater than as well, so the area to the right. So once again, we're going to have to do 1 minus this function, which reports the area to the left. Give it the x, the mean, standard deviation, and once again we want the whole area, so we are true on our cumulative. It's about 25% chance of that. Let's do C. Probability that the senior owes between $3,000 and $4,000. Let's scoot this over. Between 3,000 and 4,000. So just like we would do it normally, we're going to have to subtract the area to the left of the larger value minus the area to the left of the smaller value. So I will do that. Norm dist using the larger value first, which is the 4,000. Same mean, standard deviation, is cumulative. Make sure to close that parentheses, and then we will minus the norm dist, or the area to the left of the 3,000. Same mean and standard deviation and true. Great. So about 34% chance of owing between those two values. And the Excel has a norm inverse as well that will find the corresponding score to a probability or a percentage of percentile score. So let's do another problem to show that. This is number 27 in your book, so same section, number 27. And it says that an advertising company plans to market a product to low-income families. A study states that for a particular area, the average income per family is $24,596. So write that in. And the standard deviation is 6,256. If the company plans to target the bottom 18% of the families based on income, find the cutoff income. So they want to know what is the cutoff income that would correspond to the bottom 18%. So that means that the families in the bottom 18%, that cutoff would be right at the 18% mark, and we would want to look at anything less than that, so 17%, 16%, so on. So that's actually the area to the left, the 18% or 0.8. So this will be the cutoff score, the cutoff income for bottom 18%. So 0.18 is my area to the left in this case, and that function is norm INV, and it wants the probability or the area to the left, the mean, and the standard deviation. And so the cutoff income for that is $18,869.48. So we can find that as well without having to look up the z-score and then convert z-score to an